Hello friends, welcome back. I hope you guys have already seen the previous videos about the like basics about the Kubernetes and all that, right? So like what is Kubernetes and what are the like basic things about Kubernetes, right? Like how it functions and all. So that is what we covered in the last videos. Today we'll focus on the Kubernetes architecture. Okay, so let's go about that. So Kubernetes architecture and core concepts include the master and the slave components. Okay, so Kubernetes architecture is a client-server based architecture where we have a master node and the worker node. So there is a cluster, and inside that cluster there is a master node, and then there is a worker node. Worker nodes are responsible for actual working perspective, right? The actual work. Okay. Now, in case of the master node, there are certain components, and in case of the worker node, there are certain components that we need to understand. So, very in a simple language, Kubernetes architecture is basically a master and the slave architecture. So, there are certain clients which we call it as a worker nodes, and they communicate with the master node. So master node is nothing but the server, and all the clients are nothing but the worker nodes. Worker nodes are responsible for actual work, actual workload management and everything. And master node is responsible to hold the master components, which will give the instructions to the worker node. Okay. Now, if you see in this diagram, we have worker nodes where we have the pods running. Okay. And inside the pod, there are containers. Now, what is pod and what is container that we'll discuss in the like a future videos. So let's focus today onto the architecture. In case of this master node, we call it as a control plane node as well. Okay, so various components are there onto the master node, and there are certain components are there onto the worker node. Okay, so that is the very basic structure about the Kubernetes architecture. Now, if you see in this diagram, we have certain components onto the basically master node and to the worker node. Now, let's start with the controller manager. Now, what is a controller manager? Controller manager regulates the state of the system. The entire Kubernetes system is regulated by the controller manager. Now, there are basically various controller available in case of the Kubernetes. Namespace controller, replication controller, right? Endpoint controller, API controllers, and all that, right? So there are many controllers available in case of the Kubernetes. Controller manager regulates the entire functioning or the state of the Kubernetes system, and it manages the other controller as well. Okay, so that's how the major function of the controller manager. Another component we call it as a scheduler. Now the scheduler, what is the main purpose of the scheduler? Scheduler is the component which schedules the pod onto the node, right? Now, as we saw in the previous diagram, we have the pod. Those pods are basically running in on the worker node. Now, who schedules that pod onto the worker node? That is the main function of the scheduler. So it basically distributes the workload across the available worker node, right? So that has, so inside the scheduler there are many things, right? So it will manage it will first of all see whether a specific worker node has a capacity or not, capacity in terms of CPU or memory, right? Whether that specific machine is in a healthy state or not, right? And then only it will schedule that pod onto the basically specific worker node. Now, what happens if there are certain worker nodes which are not in a healthy state or which doesn't have a specific capacity in terms of CPU and memory? Then scheduler will not schedule the pod on a specific worker node. It will say that, okay, this specific worker node is not in a healthy state. Okay, why it is not in a healthy state? Because it doesn't have a adequate CPU or memory resources, and then it will not schedule that pod onto the worker node, right? So we have to then replace that worker node with some other worker node, and then we can take it forward, right? So that's how it is. Another basically option is into the cluster DNS. Now, cluster DNS is basically a component which provides the uh, DNS functionality into the pods and the services. Now, what is a DNS? Domain name system, right? So DNS is a basically name system which will manage the DNS naming system for the pods and the services, right? So that is the basically cluster DNS which is responsible for, right? So communication between the pods and the services, right? Now another component is the API server, right? Now what is API server? So basically API server is a kube API server which validates and configures the data for the API objects. Now what are the API objects? Pods, replication controllers, right? These are the basically API objects, right? And then Kube API server or API server is basically manages the validation and the configuration for the data of the API objects. It tracks the state of the cluster components and manages the interaction between them, right? So basically what happens, right? Whenever we have a basically data which needs to be managed for the API object, then API server is called. Let's say we need to have like we need to get some information from the pod, right? Then API server would be called. Okay, let's say you want to understand the basically health of the pod, right? Or maybe a specific pod is there in which namespace, right? Or maybe some information related to the pod, like how much memory is assigned to that pod or how much CPU is assigned to that pod, right? Or maybe whether that pod is running or not, right? All this information we can get it from the API server, right? So that is the major function of the API server. Now, another component, like another major components are like queue proxy, right? Now, what is a queue proxy? Queue proxy is a networking component which runs on every machine or every worker node or a basically node inside the cluster. Okay, it is responsible for maintaining the connection or the connectivity between services and the pod, right? So whatever services, whatever pods which we have, the connectivity would be maintained by the kube proxy. So kube proxy is a very important component. It has to be always up and running in order to ensure that there is a connectivity between services and to the pod. It will manage all the networking aspect inside the Kubernetes cluster, right? So that is a kube proxy. Another important component in this diagram is the kubelet, right? Now, what is a kubelet? Kubelet is a component which manages the pod deployment and basically the resource management, right? It manages the coordination between pods and to the node, right? So, the communication or the coordination between pods and the nodes are done by the kubelet, right? Another aspect or another major function of the kubelet is to health monitoring. Okay, health monitoring of all the objects is also done by the kubelet. Okay, so kubelet is an important component. Obviously, all the components are important, but kubelet really plays a important role in terms of pod lifecycle management, their deployment, the resource management, and everything, right? And the basically coordination between pods and the nodes, and the health monitoring as well, right? So that is the major component which we talked about the kubelet, right? Now, apart from that, we have the other component which we call it as a cloud provider API, right? Now, if you know there are many cloud providers, right? If you see AWS or Azure or GCP, right? These are the cloud providers. And what they normally do, they have their own APIs, okay, to manage the cloud resources, right? So what happens, right? We can use those APIs to manage the cloud resources, right? Now, cloud resources may be like, for example, any machine or networking or whatever it may be, right? So other components like this is also an external component, which we call it as a part of the architecture, right? So that is the case. Now, if you see here in the in the next diagram, we have this basically architecture about the API server. Okay, how exactly the API server works. Okay, now if you see here, in case of the Cube API server, we have basically the master node, right? Because the API server as a component runs onto the master node, right? We have etcd cluster, we have a cube scheduler, controller managers, and all that, right? Now what happens, right? We have a etcd cluster. etcd cluster is a cluster which manages all the configurations. It is a key value store which maintains the configuration data, right? And it will provide that configuration data to the Kubernetes for the well functioning, right? So that's how it is. Now, in case of this communication of the API server, there are worker nodes. Okay, if you see in this diagram, worker node is one, worker node two. Okay, we have these worker nodes. Okay, and then kubelet is running inside the worker node, right? And kubelet always communicates with the API server. Okay, because kubelet is a child component. It is a client component. Okay, it is a, so it is like a parent and the child, right? So child will communicate with the parent, right? And then it will get the information. So in the same way, kubelet is a client component. It communicates with the master component. And what is the master component here? Kube API server, right? So here, if you see in this diagram, we have a basically worker nodes, and there is a container runtime. Okay, container runtime engine. Okay, so API server, this is how the API server basically functions. Whenever a kubelet needs some information from the master node or a master component, it will communicate with the kube API server, and kube API server will provide that information to the kubelet, and then a end user will get the information, right? Okay, now if you see here, what happens if you see this flow? First is the authentication. So first of all, it will authenticate the user. Okay, whether this user is a authenticated user or not. Second, whether it will validate the request, whether the request is properly valid or not. Okay, it is a valid request or not. Okay, once the request is valid, then we can say that the retrieve the data. Okay, data would be retrieved. Okay, and then it will update the etcd with that retrieved data. Okay, and then scheduler will come into the picture, and then scheduler will say that, okay, where is this pod schedule on which worker node, and then function finally kubelet will get the final data. Okay, and then end user will get the data from that entire flow. Okay, so this is how the entire flow works. Okay, and then end user get the information. Now in this diagram, there is a another major component. We call it as a container runtime engine. Okay. Now what is a container runtime engine? So basically, container runtime engine is a interface which is a main protocol for the communication between kubelet and to the container runtime. Okay. So there is an interface. We call it as a CRI, container runtime interface, which is responsible for communication between kubelet and to the container runtime. Now, what are the different container runtimes? Docker, Rocket, right? Or basically container D, right? These are the container runtime available in the market. There are the others as well, but the Kubernetes supports all these container runtime. Okay, so most popular is the Docker. Okay, other one is the Rocket. Right, so you can use any container runtime, and Kubernetes supports that. Right, so container runtime basically we have seen in their previous videos as well. Like container runtime allows the communication between the kubelet, okay, and the container runtime. Okay, so it is an interface. Okay, and because of this container runtime, we get all the resources to the pod, right? Whatever container or whatever pods which you are going to run on the EC2 machine or whatever like machine, we get all the resources using this container runtime. So container runtime manages the communication, okay, between the kubelet, okay, and the container runtime. Okay, so that's how it is. So this is how basically the architecture, okay, and the component of those basic architecture of the Kubernetes, right? I hope you understand the Kubernetes architecture perspective, and then I hope you clear all the concepts and all that, right? So please feel free to subscribe to this channel, okay? And then if you have any doubt, put into the comment, and then we can probably try to address to that. Okay. Thank you very much for watching this video, and then we'll meet soon. Thank you very much.